Hello. Morning. I made the answer key for chapter 12 test. It seemed like a really simple test to me. Lots of whole numbers, answers. You guys there? Can you hear me?
Yes.
Yeah. Okay, good. Thanks. So you're going to want to probably pull this up, this problem. I guess what I could do is I can start off with a share screen. I'll start doing that more. I got to change my, I don't want annotation. Advanced sharing options. Only host can share. I want to block annotation. I don't really know how to do that. So, well. Okay.
Hello.
Hello. There we go. The Golden Gate Bridge problem. I've been seeing this problem out there this year. For some reason, it just keeps popping up. When you have sag on a rope, you know, and held up between two pylons. Probably do more screen sharing. Oh, it allows me to annotate. Are you guys able to annotate on my shared screen?
I don't think.
Yeah, you
so.
are. Yeah. Can you erase that, please?
Yeah, but you shouldn't do that.
Okay.
I don't know how to stop annotation.
Oh, there's a way to disable it.
Now try it again.
No, we can't.
I can't do it.
Okay. I wonder, can I do it? I don't want to do it, but okay, draw.
No, like you could like draw a line on a certain distance or something.
You saw my little drawing there, right?
Yeah, like the little arc.
Okay, so I can annotate, but you cannot now. Okay, good. I learned how to do that.
Why
Good.
is the 220 feet important?
What?
Why is the 220 feet important?
For you to determine whether it is important or not. I did not take a picture of the solution for this. So whatever we come up with is what we come up with. I'm okay with that. We should be able to together reason through any problem that they throw at us. And if not, I'll call Mr. Knaus and we'll get him on here. Just kidding. Don't let a textbook problem ever stump you. If a problem is difficult in a textbook, you should get excited and do any research you need, go on YouTube, whatever you need to research, and don't give yourself the answer. Try to figure it out because, you know, if you're getting into the sciences, you're going to have to solve problems without anybody being able to help you. You're never going to get to the cutting edge of anything unless you practice that type of thinking.
Wait, is the road the x-axis?
I don't know. Look around.
Oh, h, right.
Look around, explore the drawing. Can you guys see the rightmost part of the picture?
Where?
The rightmost part of the bridge?
Yes.
I see the arrow that says x.
Aha, there you go. That's a giveaway.
I know.
That's the x-axis. So now you know that 220 is below 0.
It's not important.
Well, you're saying that, but let people determine that on their own.
There might be a future question where it's how high is it from the ground or the water?
Yeah. What is h above the, okay, what is the height h? Oh, but it tells you what height h is. Yeah, oh, you're saying a different question could be asked. Yes. Okay, now that we've started, let's take a look at this problem. So everybody's seen the problem, and I will stop sharing. So hopefully you guys have this up somewhere else, and then we could discuss it here. All right, so let's write that equation down. This equation describes the pathway of the cable between the pylons. And this problem's not too difficult. Have your calculators out. Be ready to do some calculations. Or have another window with Desmos open. You can do it on there. All right. So, yeah, if you use Desmos, you can find minimum and maximum points pretty quickly. So, but that's not helping you to learn as much. So it's better if you we're trying to manually do these things right now. We're not trying to get to the end. Getting to the end is not what we're doing here. We're trying to explore this problem. Okay, so here's the equation that describes the pathway here, and it's parabolic, all right? This function is a quadratic function, all right? So the height of this is from the x-axis, they've labeled here. So that would be the y coordinate at that minimum point. How do we find the y coordinate, the height, the vertical distance of the minimum point? Well, we have to do something first. We need to find out how far over that is. And that's not given. It doesn't say how far apart these 500-foot pylons are. Okay? So you don't know where that is horizontally. So the first thing we're going to do is find out where that is. And through the calculus, we learn
Negative b over 2a.
the derivative at the minimum point is 0, because this derivative, again, a reminder, a third time, is the slope of a tangent line to the graph. Okay, and the slope is not 0 anywhere else. It's only 0 when you bottom out at the minimum. And if it were a maximum, it would be a maximum. But this is a minimum because it opens up. Okay, so the slope of the derivative is 0 here. All right, so what we did when we had this equation is that would give you negative b over 2a would be what the location, the x location of that minimum point. So we're going to do negative b over 2a here. Okay, negative b, here's b, is negative 7/15. Oh, I have it a little dark in here. Is the lighting okay? Tell me if the lighting is better now.
Got slightly better.
It got better. Okay, good.
That's fine either way.
Fine either way. Well, I opened up the blinds, you know, so that let in light. I don't know if that's better or worse. Okay, so then negative, here's b over 2a is a fraction. And with a little bit of simplifying, you get positive 7/15 multiplied by the reciprocal of this product. The product here is going to be 1 over 4,500. So it's going to be times 4,500 over 1. 15 goes into 45. It looks like they did that for us on purpose. You get 300 times 7, which is 2,100. So I have the x coordinate is 2,100 feet from the pylon. So I could answer another question. I could say, how far apart are these pylons? Go on.
4,200 feet.
They're 4,200 feet
Yeah,
apart.
4,200.
Uh-huh.
Wait, I don't understand why that gives you the distance between the pylons.
Because
2,100 distance to the axis of symmetry, to the very
Yeah.
middle.
to
Oh.
the middle is 2,100. That's the midpoint. So
Yeah, and it's, you know, that's the vertex is on the axis of symmetry. And remember, the left side and the right side are reflections of one another.
Okay.
Okay, so to the halfway point is 2,100. That means all the way would be 4,200. Okay, but that still doesn't tell us h. It just tells us this distance to get underneath h. Now, how do I find h? Well, remember, it's a solution to the function. What is a solution? It's when you plug in it's when the xy coordinate of any point on there, when you plug it into the equation, what would happen? Is a solution. If a solution
They
is
stopped.
a solution is a point on the graph, but in the equation, it makes the equation true. Well, then by plugging in this x and finding out what y would make it true, you just plug in 2,100 here. Okay, so now, here we go. This is where you might get out the calculator. So I'm going to plug it in, 1 over 9,000 times x squared, x is 2,100 at that point, not always, just at that point, minus 7/15 times 2,100 plus 500. Okay, when you do all this stuff, I think that you're going to get negative 490 plus 500, and I think you're going to get 10 feet,
yeah.
which is your solution. So that coordinate is at 2,110, 10 feet off the bridge.
Yep.
How did you do that so fast, Mr. Rosenthal?
Because I did the problem before we started.
Oh no, I was kidding.
Oh yeah. I did this part and I remembered that it came out to negative 490. I got worried for a little bit that I was doing something wrong. I was thinking, uh-oh, it can't be negative. It doesn't drop below the bridge. And then at the end, I saw that 500 and I matched it up and I said, oh, perfect. And then I felt a little awkward that, does it really come that close to the bridge? And I guess it does. So the cable drops down all the way till it's only at, so somebody who can touch the backboard, right, on the basketball can probably jump up and touch the cable. Any questions about this? These problems are fun to me. This is, you know, really working with the math to apply it is so much more fun to me to solve a problem with it.
Wait, so Mr. Rosenthal, what's the point? So the height is 10, but what's the XY point?
2,110.
2,110, it's not what they asked for. They asked for just what h is. That's just a y coordinate only. So the answer is 10 feet. Cable is 10 feet off the ground at that point. What is the height h above the road of a cable at its lowest point? The answer to that is 10 feet.
Okay.
Okay, but if you were to make it a coordinate, it would be 2,100. We got that with negative b over 2a, which we know came from the derivative being 0.
Although if you do look it up, quick immediate research says that the Golden Gate Bridge has a clearance height of 14 feet, which means the trucks couldn't pass, but I don't think it's 10. Actually, 1 second, let me check.
Trucks are not passing under the cables. The cables
Yeah,
are
clearance height is different than the cable
Oh
height.
yeah, that's at the toll gates. Never mind.
Yeah, you're not passing under the cable. The cables are on the sides of the bridge. All right.
It's not good if you're passing under the cable.
Yeah, it's not good if you're
Yeah,
passing.
then something's wrong.
Yes, I agree. All right. Shall we move on to the next problem?
Yeah.
Okay, then I'll do it first, I guess, up here. It doesn't matter. This one might get tricky. Okay. And I'm going to put this up here because I can't fit it on any other way. So let's go ahead and share screen again. And let's move down here. Okay. In 1971, astronaut Alan Shepard, I got to get
Oh
this.
yeah, he hit the golf ball.
Hit a golf ball. Oh, you knew that? I didn't know that.
Yeah, I
Hit
read
a
it in
golf ball on-
GScript.
Yeah, he hit a golf ball on the moon. The path of a golf ball hit at an angle of 45 degrees, and I'm going to show you this picture here, and with a speed of 100 feet per second. And they give you they make it easy for you. You know, in the real world, or in a more difficult situation, you would have to write the function yourself. But here it's given to you, negative g over 10,000 x squared plus x. And you might be thinking, well, there's a third variable there. Well, they're going to give you that, right? X is the ball's horizontal position in feet.
G is the gravitational constant.
I want to bring this to your attention. In a lot of times when we do these projectiles, the x-axis is not horizontal position, it's time. So I want you to be careful with that this is modeling horizontal and vertical position, and normally it's vertical position with respect to time. Okay, so dy dx is going to mean something different here. All right, dy dx is the change in horizontal with respect to the change in horizontal. I know that you might be thinking, well, isn't that what it always is? Well, when it's time, dy dx is something different. Now you're talking about things like velocity and acceleration. The change in position with respect to the change in time is different than the change in vertical position with respect to change in horizontal position, right? It's just a different dimension. Instead of measuring two of the, I don't know if they have a word for it, traditional
First dimension and the fourth dimension.
The first three dimensions, I'm going to coin them as the traditional dimensions, where we have length, width, height, things like that. And the fourth one as the extra dimension, because that's just how we're used to seeing it, but there's nothing in that.
Fourth dimension is always exact.
Yeah, but anyway, all right, so let's get back to this problem. So the path of a golf ball hit at an angle of 45 degrees and with a speed of 100 feet per second can be modeled by this equation. X is the ball's horizontal position in feet, Y is the corresponding height in feet, okay? And G is the acceleration due to gravity. That's gonna change. If you notice the picture, one of them's on Earth, one of them's on the moon, same hit. If you hit the golf ball the same way, and look at what they give you. They give you G. Okay, so for A, use the information in the diagram to write functions for the paths of a golf ball hit on Earth and a golf ball hit on the moon. Well, that's not going to take anything other than plugging in. So by the time I'm done doing it, you should be done doing it. And I have to erase and all that stuff. So. All right, let's see. So let's do Earth. We'll do Y subtext E for Earth is equal to, the G is 32 feet per second squared. That's acceleration due to gravity. And we're going to express it as negative. Why on earth would we do that? Get it? Why on earth?
Bro, no.
That was good, Mr. Rosenthal.
Negative.
Mr. Rosenthal, stop.
Why negative?
It's because it's a force pulling down.
Yeah, and you know,
Unintended.
vectors, how do we express opposite directions with vectors, with positives and negatives? Negatives are opposites literally in math. Then negatives and positives are literally opposites in mathematics. So if you need to go opposite directions, then that is why we have a negative to go up or down, left or right. So in this case, acceleration is going towards the center of mass of both bodies, right? And for us, from our perspective, it appears to be down, where going up is really going opposite the direction towards the center of mass, right? But we're calling it up, right? Isn't that interesting? Maybe not? Sorry. Okay, there's my Earth equation. And by the way, I know Surin must be a little bit upset about this, that it's in feet per second squared.
Yes, I was going to note it. Basically, every scientist on Earth says 9.8 meters per second squared. Couldn't they bother to?
Mr. Rosenthal, we can't see your equations because there's a screen in the way.
What?
We can't.
You could say it's taking up too much space.
Oh, you can't see my screen. Yeah, okay, fine.
No, guys, you can switch the videos.
Oh, you guys can switch your videos?
Yeah, there's a button on the
great.
top.
Great. You guys do that then. Switch your video so you can see me, what I'm doing when you need to.
There's a button that says swap shared screen with video.
I'm going to put a sub.
Top right corner
I'm
of the
gonna put
little
sub-
dialog box.
for my-
Wait, that's what I did too. I put a sub E and M for Y.
Yeah, I'm going to put subtext here for moon. And for the moon, it looks like we have 5.3 feet per, so much less. And it's negative. Wait, oh yeah, and it's going to come out negative because it's going down. For us, it's down. Yes, sir. Yes, ma'am.
Guys, how do I switch it? I can't figure it out.
Hi.
On the top
You
right.
can just pin his video and it'll automatically switch.
It's already
Oh,
it's
yeah.
already pinned.
In his video and then in the top right corner.
X for the moon. All right, so I have I think I fulfilled what A was asking for. It says use the information in the diagram to write functions. Now you could put them in function notation, f of x, right? But that's fine. They're using y, we'll use y. Doesn't mean it's not a function. Any questions about that? Ask now. I'm going to stop sharing the screen for a second so I can look for any questions. Remember, if you're typing stuff in and I'm sharing screen, I can't see my chat window unless I hit it again. Anybody? I'll look for any questions so far in the chat. And I don't see any. Go back to share screen and we'll bump it down to question B now and C. Let's just go to B. Graph the functions from part A on a graphing calculator. How far does the ball travel on Earth, on the moon? All right. I guess that means it's Desmos time.
Desmos.
You guys can go to your own Desmos, and I think I'm going to go to Desmos here. Desmos graphing calculator. You guys can still see my screen, right?
Yep.
Yep, because I didn't stop the share. Okay, let's do our first one for Earth. Y is equal to, I'm going to put, I don't think I need to, but I'm going to put the parentheses, negative 32 over 10,000. Close them. Oops, tab, close them. X, yes. Shift 6 square. Oh, wow. Thank you so much.
He brought you a burrito.
Yes. Oh, you heard that. Okay.
I was worried he brought you garlic.
You guys should practice with the Desmos here. Plus X.
Wait, how do I do x squared?
Something's wrong. It's Shift 6 gives you the hat. You put a 2 there, and then you
Mr.
tab.
Rosenthal, what do you mean by something's wrong? Does it look like a straight line?
Yeah.
Oh, you just have to scroll out.
You guys need to zoom out. Zoom out. Yeah.
Oh, thank you.
Yeah, that's the problem.
I thought
Wait,
the same
what's
thing.
the
I thought it was
function?
fine.
Can you scroll back
Giant
up?
parabola.
Can you scroll up on the share
Scroll up.
screen?
Scroll up where? On what
Shared
screen?
screen.
Oh, my shared screen?
Yeah.
I can't. What do you mean scroll up? I'm on the Desmos, right? Aren't
Can
you?
flip back and no, we can't see you,
You can
Desmos.
only see the
Oh, because okay, so I have to go back to my.
Switch the tabs.
Oh, I didn't see the tabs. Let me go back. So now do you see it?
Yeah, we see. Yeah.
Where are the tabs?
Do you see on top? There's the tabs. We see those.
I don't see the tabs.
It says session, timeout, Desmos, staff organization, channel videos.
Oh, I can just go to new share, it says. So I can just hit new share. Okay, so that's what I have for that red one. Oh, I got a love letter. Let's see what the magic letter says. From Jack. It says, can you guys see this? I love you so much. How are doing? I love you, love Jack. Oh, that was nice.
That's cute.
Yeah, very. All right, so let's just examine this Earth graph. And let's take a look at what we're looking at here. Remember that the y-axis is the vertical position. You can see where the maximum point is if you put your mouse over it. 78.125 feet is the maximum height the ball reached. See that? You guys can see my mouse too, right?
Yeah.
So you see how Desmos puts important points for you? Then you can just hover your mouse right on that point and you have your maximum. Pretty cool, huh? So, you know, that's available to you when I give a test. So practice, practice. Another thing is, another question they might ask is, when does the ball hit the ground, right? So let me see, what was question B? Graph it on a graphing calculator. How far does the golf ball travel on Earth? And how far does it travel on the moon? Before you graph the second one, is it going to travel farther or not on the moon?
There.
Farther.
By the way, Surin, do you know the difference between further and farther?
Well, I guess.
Further
Well,
is
actually, I
to, further is
See,
to.
farther is used for distances.
No, wait. Further, yes, further you would use to, if you're talking about advancing in particular an idea further. I don't think I've seen anyone. Well, actually, you
I
could
think
say
farther
go.
is for distance, and
I
further
think-
is for everything else.
But they could be alternated, although
Maybe, I don't know.
that would be strange. Yeah.
That's your homework. I want you to check that out. Okay, I'm going to
Further
go ahead.
is used for
what do we
philosophical
have to do for
metaphorical
homework?
distance.
Oh,
from
no,
farthest
that's
to
Thurin's homework only. He has
Oh, okay.
specialized homework. Okay, now listen. If the ball is hit on the moon and there's less gravitational pull, what would you expect the ball to do?
Go no longer.
Would it go higher?
Probably.
So it should go higher. It'll have the same starting point on the ground, 0, 0 from the origin. But I think, will it go steeper? Will it be a steeper curve? Or will it just be a translated curve? What's going to happen here? Is it just moved up? Is it?
It will be a more like stretched out curve. It should be like
Yeah,
wider.
stretched.
Well, let's look at the equations. I mean, is the coefficient of x squared determines that, right? The negative makes it upside down. And then the bigger the fraction, or the bigger the value of the coefficient, the steeper it will be, right? Right now, it's pretty flat. 32 over 10,000 is very flat. Okay, so and the other one is going to be, the other one's going to be flatter, not steeper, right? The moon is 5.3 over 10,000. That's a smaller value. It's a smaller absolute value. So it should be wider, right? Not steeper. You agree?
Yes.
Okay, let's actually graph it then. New graph. No. Here we go. Y equals parentheses negative 5.3 divided by 10,000. Nope. Tab parentheses x shift 6. I'm trying to help you guys that aren't familiar with this. It's interesting to see what's happening there. Okay, and tab plus x. Yeah, look at that. Okay, now I have to zoom out more. Wow, that golf ball, look at that.
Golf balls are cool.
Yeah.
Frog trap, frog trap.
I think they're cool too.
Science behind them and how much advancements that they've made into like a tiny little ball is really cool.
Okay, so what did we say the maximum height of the on Earth was 78?
156.25, 708.
This one is 78 feet about, and then this one, when I click on the blue one, there's the maximum point. 472 feet.
900.
Wow. Wow, look at that. And then the curve is way flatter.
I concur that the moon's gravitational pull is less than the Earth's.
Okay, and then we can answer questions like, how far did the ball go? For the Earth, it went 312 feet, 312 and a half. On the moon, it went 1,886.792 feet. All right?
What were the y intercepts? 0.
The y-intercept is
0.
0 because you started from the ground. You didn't start on a platform, right? Your y-intercept is your altitude at the moment that you're, of when, if it's with time, it's when time started with respect to your problem, your situation, or in this case, the x, when the ball has not traveled any horizontal distance, then it has not traveled any vertical distance, because they're both distance here. Okay, so it says graph them. How far does the golf ball travel on Earth and Moon? That's the x distance is what they're talking about. So 1886, 1887 on the Moon, and what was that value we had on the red one?
Would it matter if there was x distance or the y distance? Because you could say that.
It's displacement.
Yeah.
You guys see that? So that's a great interjection. What Zig is getting at is that, well, the ball actually traveled further than that, didn't it? The displacement, though, is what they're talking about. When you hit a golf ball, it doesn't matter how far it traveled in the air, because the goal of golf is to get it into the hole, right, at the end. So when you're talking about in golf how far you hit a ball, you're really talking about displacement. You don't care how far the ball traveled in the air to get there. How would you figure that out?
You would have to extend the circle.
No, there is no circle, but I think I was just checking, anticipating this conversation happening, and I believe there is a method to calculate the length of a parabola arc.
There is. I've seen this. That's where when I saw this, when I talked about, I keep seeing this problem come up. The problem actually was about that, was how do you determine the length of that? And I believe that I remember that there were some equations that are there for that. I don't know them off the top of my head, but that's another thing to look up. Okay, but that would be interesting. And just so you know, it is measurable. So you could find out the distance traveled along that pathway that the ball took. All right, compare the distance.
Would the two parabolas be like similar?
Okay, that's an interesting idea. I would say that they're similar if one would dilate and translate over to map onto the other one, right? So how would you do that? They would have to have the same coefficient of A, maybe? Or, yeah, they would have to have the same coefficient for A, wouldn't they?
Yeah.
So it's an MIT OpenCourseware PDF that says that in order to find it, you would have to integrate the function from 0 to a, and the function would be square root of 1 plus 4x squared.
Okay, and integration, by the way, just so you guys know, is in the second half of Calculus AB, you're going to integrate, which is just doing the opposite of the derivative.
Well, that would be if it's an antiderivative, but integration is just finding the area under the curve.
Yeah, you use the antiderivative to do that, though. I'm talking about the methodology. So what you would do is you would, if you use the power rule that I showed you, you would do that in reverse, and then you would do that between 2 points, not just at 1 point, and then you would subtract. The value from the point the point farther to the right, you would take that point and subtract what you got when you plugged in the point to the left, and that area between those two would be the area under the curve. We're getting way ahead of ourselves now.
Yeah, in fact, I believe there's integral calculus has sort of a power rule of its own, in that if you're integrating a function x to the n, its integral will be x to the n plus 1 divided by n plus 1. So x squared would be x cubed over 3, and x would be x squared over 2.
That's correct, but I don't want to get too far into that. Okay, let's take a look at what else if they have anything else to add here. Compare the distances traveled. We did that. Answer should include the following: a calculation of the ratio of the distances traveled. The ratio of the distance, what does that mean? Oh, make a ratio? So you just put one over the other? A discussion of how the distances and values of G are related. Oh, well, we talked about that because as if you guys want to pin my screen up, put my tab up, if you change this, the smaller you make this value, absolute value, the wider it's going to get. All right, so as you have less gravity, you're making this value less. The 10,000 is a constant. All right. Okay. I think we get the 10,000 by squaring the 100, by the way. In the given information in the beginning, it said the initial speed was 100 feet per second. So I think they squared that to get 10,000. So I think if you hit it at a different speed, it's going to change the 10,000. All right, let's go to the next problem. This is the challenge problem. I want to see if you guys can get this without, looking it up. So let me go ahead and do a new share. This one's an interesting problem. Lifeguards at a beach want to rope off a rectangular swimming section. They have P feet of rope with buoys. In terms of P, what is the maximum area that the swimming section can have? Be careful with what they're actually asking you for. Because in this problem, the hardest part is the beginning with how to get it was like the go-kart problem was the hardest part was how do you set up the function? Like I said, that makes the problem more difficult when you have to set it up. But what you're trying to get is a quadratic. So you have to be trying to find a way to get a quadratic. Once you do that, that's fine. That's the hard part. Once you get into the next part, though, you might be tempted to answer a question that's not being asked of you. Like, what is the length? What is the width? Okay. What is P? Right. What are all these things? They're not asking for that. They're asking for the maximum area. By them saying that, they're giving away the relationship between the function and what is going to be what in the function. Remember what a maximum is, right? What would a maximum be? And then it tells you, oh, I know what the y and the x should represent. Once you know what the y and the x represent, that'll help you make the function. This one's fun. When you figure out what the function is, it's quite fun. I'm going to give you 2 minutes. In 2 minutes, you can start throwing some ideas out for those that are struggling. I could do problems like this all day. Not all day, but instead of just, these are more fun to me. We have to learn the fundamentals, but then this is the reward to me. Learning the fundamentals and this is how you do it. And I mean, I guess that's good too, because then you make these discoveries that when you see, oh, that's a cool tool. You know, a lot of students don't realize that the tools you're getting are neat. They can be thought of as neat tools to help you solve problems that you couldn't. Now all of a sudden you're realizing you can do all these problems. Does anybody have the function already and what the variables stand for? Is there a single person there that has it? What the function is?
So P is 2W plus L.
So I guess we're talking about it.
P equals 2W plus L.
Okay, so if you notice, you are using these buoys, okay? You don't have buoys along the shore. So some students will just go right to, oh, perimeter, 2L, 2W. But David sees it's only 2W and 1L. Okay, that's fine, but that's a linear thing. That's not a quadratic. We need to see something that gives us a quadratic so that we can find a maximum point. We're starting to understand the maximum and minimum points, but this is not a quadratic, so we don't understand maximum and minimum in the linear. What's the maximum point for a positively sloped line? There is no maximum point. Or a negatively sloped line. There is no maximum point. There is for, if it has a slope of 0, there's a maximum point. There's a maximum altitude. And for a vertical line with no slope, there's no maximum or minimum. Does anybody have anything other than this that they can get out of this?
A is equal to 2.
Oh, okay, wait. What's A?
A is
Well, you can't say
LW.
L times W because there's,
A
you can't
is
say
what?
that
What is A,
because there's a
Zig?
shore.
Hold on. What is A, Zig?
The first letter of the
LW.
alphabet.
No, what does A mean? Why are you using the variable A? What does it stand for?
the area
Ah.
of
You're trying to maximize area. So that's the same thing when you have a maximum point on a graph. That's the maximum what? It's not the maximum x. There are greater values of x over here. To the right is greater with respect to x. So if I move to the right, that's a greater x coordinate. Okay, so the maximum is not with respect to x. It's with respect to y. So when Zig is saying A is equal to, we're trying to maximize A, we're trying to maximize y. So area is y. Okay. Area is treated like y, okay? And so area is equal to, now you guys know it's a rectangle. Go ahead, Zig.
LW.
LW. LW. L times W. Great. We're making progress. With a little substitution, you're going to get a quadratic.
Is P X?
By the way, this needs to be in terms of P. In terms of P. So P is going
It's
to
probably X.
be your problem. Give me 1 second. Yes? Oh, nothing? Okay. So when this says in terms of P, don't get upset that you're not going to have a number here. You can try this out by putting in a number. I did when I did this problem yesterday. I put 100-foot, I gave myself a 100-foot buoy just to check to see, give myself a numerical example so that I could use inductive reasoning, right? To get an observation of what it might look like with a real example. That's a problem-solving strategy. Where do I go from here, folks?
I think X is P.
I need to plug something in for either L or W. So I think I'm going to solve for L because I don't have to do any division.
It's P over 2W, right?
I'm going to subtract. I'm going to come over here and I'm going to say that L is equal to P minus 2W by just subtracting.
Sorry, minus.
Okay. And then I'm going to go ahead and plug it in here. So area is equal to this L times W, and I'm going to substitute P minus 2W. Now, we'll angle this down.
Negative 2W squared plus WP, maybe?
Here we go. Area is equal to PW minus 2W squared. And we want to turn this around. Negative 2W squared plus PW. We now have our quadratic. Okay? Area is equal to this. To maximize area for this curve, by the way, what direction does this curve open?
Down, it has a maximum.
Yes, it opens down because this is negative. And so it does have a maximum. So that's a good check to make sure you're doing this right. You needed to see that there to make sure you were actually going to get a maximum out of this and not a minimum. All right, and then we know where the x coordinate of that maximum is. Where's that? Negative b over 2a. Okay, so the x, but it's not x in this one. What is it? W and x. W is being treated like the x. Okay, so it's w here. W is going to equal negative b, which is the p here, over 2a, and the two negatives will cancel out, and you're going to get p over 4. And that means I can have any length rope with buoys attached. And you're basically dividing it by 4.
So if you used 100 feet like in the example, Desmos indicates that the maximum area that you can
Well, no.
enclose is
That's, you're going to the answer. We're not there yet. This is the x coordinate. It's not what the answer, what we want is the y coordinate, right? Remember, look up here. We want the maximum area. I gave you what the width would be. I gave you what the width would be for the maximum outcome for area. That's what I have so far. P over 4 is not the maximum area. P over 4 is what the width would be when you have the maximum area. Okay? So all I need to do is plug it in. Okay? Where am I going to plug it in?
W.
Plug it into W where?
P4 into W.
What am I trying to do?
P4.
I'm trying to express area in terms of P. Where should I plug this back in? Where along the way?
Right before. 8.
into W.
What color?
And
Purple.
The first purple, the second purple, or the third purple?
Third purple.
Third purple.
Fine, third purple, yes. Let's plug it in here and see what happens. So I'm going to take this one. I have negative 2w squared plus pw, and w is p over 4. And I probably have to angle down a little bit more. It's going to be a little glary. Who's glary? Okay, so this is going to be p squared over 16. You see that? Then it'll be negative p squared over 8. That's what this simplifies to. This will be p squared over 4, but I want a common denominator, so it'll be 2p squared over 8. Somebody's going to ask me where I got the 2 from. Common denominator. And then this will, these are like terms, so you're just going to get p squared over 8. And what does that equal to? I plugged it in here. That's your area at the maximum point.
wait a second, how'd you change them to 8, Mr. Rose? I thought you said common denominator, but
Here,
how'd you
this is
get that?
what would this be before I do anything? P squared over 4, right?
Yeah.
P squared over 4, but the first term,
Oh, you multiplied it by 2 and
Right.
you multiplied both of them.
P squared
by-
over 8. Okay.
And what about the other one? How'd you get that to be 8?
Okay, so p squared over 16 is what you get when you square it, and then it's times 2.
Oh yeah.
Okay.
Never mind.
All right, so then I have this, and what I get is this, p squared over 8. And that's what the area is, and that's the answer. And I'm sure, is that what you got in Desmos?
Well, in Desmos, well, it depends on what you plug in for the area. So, Mr. Rose, I'll plug something in and we'll check.
Okay, so let's take let's do if the rope was 10. Let's do if the rope was 100. If the rope was 100 feet, right? That's what P is here. It's not the full perimeter. It's just how much rope you have. If that's 100 squared is 10,000. 10,000 divided by 8 is 1250.
That's
So the
correct,
maximum
Mr.
area would be
Rostal.
1,250 square feet is what your answer would be. Not only
Yes,
that, check the width too. What was our width? P over 4 was our width?
yes.
So that would mean the width was 25, right? If the width was
Mhm.
25, and that's 25, then the length, all that's left for the length is 50. So 25 times 50, and you'll see that's 1250 also.
Desmos indicates that you are correct, Mr. Rosenthal.
Well, thank you, Desmos. Tell Desmos that I indicate that Desmos is correct. Sorry. Pride is the source of shame. Okay, moving on. All right. Now we'll get to the lesson. Graphing quadratic functions in vertex form. All right, so let's go back to this, and Maybe share the screen again.
Mr. Rosenthal, is that the answer?
Yeah, b squared over 8. All right, so here we go. In lesson 4.1, you learned that the standard form of a quadratic function is what it is. Ax squared plus bx plus c is equal to y. A can't be 0. Now we're going to get into vertex form. This is equivalent to the point slope form. What did we tell you that point slope form was good for?
You are given 2 points.
Translation. No, that's what you answered. And then we talked about, translation of functions are all going to take this form with the HK in there. HK, by the way, is what? What is HK going to be?
The vertex.
It's going to be the vertex here. All right. HK doesn't always have to be on the graph. You know, like with circles, the H and the K are the center, which is not actually on the circle. Okay. But in this case, it looks like the HK happens to be a point on the parabola. All right. So vertex form, let's take a look at vertex form. It's A times parentheses x minus h. What is that minus h? What is x minus another x coordinate? What does that mean?
0?
No, it's not what I'm asking. What is when you have one x coordinate and you subtract?
Delta x.
Distance.
It's delta x.
Yeah.
Yeah, or a displacement or a distance, right? It's a change, a horizontal shift. Okay? And it does not mean that you're moving to the left. You can move left or right. It just depends.
And if it's x plus h, you would have to move to the left because x would have to become negative in order to push it to 0.
Yes, in order to push the value to 0. Okay, without a k being there, right? It would be 0, and then a k could still bump it up or down. But that's neither here nor there with respect to what's happening horizontally. Okay, because why? Why does the vertical not affect the vertical change not affect the horizontal change directly?
Because they're not.
Those dimensions are perpendicular to one another. Remember, we talked about that. They don't affect each other, but they both work on a locus of points together. Like on your Etch-a-Sketch, moving the 2 knobs on the Etch-a-Sketch, moving one knob doesn't do anything to the other knob. Okay, but when you move them together, it does something to the drawing. That's a good way to put it, I think. What do you think A is going to do to it? Just from our experience so far, what do you think A is going to do?
Process, they sell like a, I don't know, probably like
I think it might be the make it more make the slope of it more make it more steep and more shallow.
Yeah, how would it make it more steep?
If A is bigger, it might make it
Bigger than what?
Bigger than 0.
1. Bigger than 1 is what
Bigger than 1.
Because y equals x squared is a standard parent function.
Bigger than 0 means it's going to open up. Less than 0 means it's going to open down. More than 1 means it's going to get steeper than the parent function. Between 0 and 1, it's going to get wider than the parent function, right? And then what is plus k going to do? Okay, take a look at this. I see delta x, I don't see delta y. What the heck is going on here? Y is equal to a, x minus h, there's a delta x squared because it's a quadratic, plus k. Where's my delta y? Subtract k on both sides. There's my delta y right there. Divide by x minus, let's just examine doing some manipulation here. Divide by x minus h on both sides squared. Delta y over delta x, now it is squared, But if you look at it, delta y over delta x should be what?
Slope.
So A is slope, isn't it? But in a two-dimensional sense, right?
A is
That's the slope formula. y2 minus y1 over x2 minus x1.
x2 minus x1 is squared, so
Right, it is. Well,
that's why it's different.
What would happen if you just divided by 1 x minus h?
Then it'd be the x minus x ax minus ah is equal to slope at a given xy.
It's the slope times delta x.
Wouldn't a times x minus h be the slope at any given xy?
Yeah, I mean, no, the slope at any one given xy. I don't know. Now we're getting into stuff I haven't done, but we're just playing around with it. So if you can make that determination, maybe you can explain why you think so. But anyway, I want you guys to understand this form here. Makes life easier for us when we learn this. This is just a transformation. Where's the parent function? The parent function is if there's been no translation. H is 0, K is 0. Then you just have this, where A is 1, right? There's the parent function. All right? So this is horizontal shift from 0, 0. This is vertical translation from 0, 0. And this is going to tweak the slope. All right? So that is what's going to help us to do this next section, is to graph from vertex form. All right? The new vertex is at, so all you have to do is pull the h out. If that's minus, then that's just the number positive. If this is plus, it's negative. Okay, and then this is just whatever it's showing here, plus k. Whatever k is, that's the so now you have a quick way of locating the vertex of your parabola. If it's in this form, I can quickly know where that, or if it's this way, if a is negative, I can quickly find that point, and I don't need to do negative b over 2a now, right? So what does it
know?
This allows us to not have to calculate negative b over 2a. When it's in the standard form, we find the vertex by using x equals negative b over 2a.
Wait, does c equal k? Wait, no, it doesn't.
Hold on. But in vertex form, you can immediately extract the vertex immediately from there, no matter what a is.
Wait, is k the y-intercept?
Okay, what happens when the value here is 0?
Oh yeah, it would be minus the center, minus the vertex.
So if x is 0, you are on the y-axis, correct?
Yeah.
Okay, but if
That thing's not.
this is going to shift it, if this has a value other than 0, it's going to shift it to the left or right, and you will no longer be on the y-axis. So no,
Yeah.
this will not necessarily be the y-intercept in this case. In the parent function, it is. Okay. It would have been if it wasn't shifted. Okay. All right. All right. So this will be vertical shift, vertical translation, horizontal translation, slope. HK will be the vertex, so you can locate that. And we saw in those word problems the value of locating the vertex, minimization, optimization. Okay? All right, great.
What is H comma K is the vertex?
A is
No,
slope.
A comma K.
A comma K.
H.
H comma K is the location of the vertex.
Okay.
Okay. Before I erase that, let's go a little bit further here. Screen share. Okay, let's see. Any other x? The axis of symmetry, of course, is going to go through HK, which means x is equal to h. And we talked about graph opening up and down is the same. It's based on A. Go ahead and try to graph that one, please. And I'll give you a 30-second head start. Try to use new techniques. Don't try to convert this back into a problem that you already knew how to do. All right, you've had a head start. Here's how I would do it. I would start with where the vertex is. I put a V. The vertex is at -2, 5. Okay, any questions about how I got the vertex? No? Okay. What other points can I find?
Well, why is x -2?
Okay, let's start with the parent function like that. And then let's just talk about simply that. So the only thing that I've changed is that. So you can not focus on these other things. The graph of this one, can you see? Can you see that, or do I need to lower it a little bit? Let me lower it. Okay. The graph of the first one is like this, right? Where the vertex is at 0, 0. That means when x is 0, 0 squared is 0. What I want you to do is track the vertex. Don't track the rest of it. Where is that going to go so that y is 0? We want to track which way it moves, left or right, because this is a horizontal change, right? Your question is not whether it's horizontal, it's whether it goes left or right. So you're either going to move this point to the right or you're going to move it to the left, all right? So what does x have to be to keep this point on the x-axis? What does it mean to be on the x-axis? It means that your y-coordinate must be 0. So in order to keep your y 0, to stay on the x-axis and also not move up or down from there, just side to side only, in order to do that, what does x have to be here to make that 0?
Negative.
So x has to be here in order, so this point moves here, so that when x is -2, y is still on the line. Notice it did not bump to the right. So you have to think in here, how do I make this 0 is the thought you have to get back to the parent function. To get back to the parent function, you have to make this -2, right? So to find that vertex where it would have been starting at 0. Okay?
Thank you.
So in here, it's going to be the opposite of the sign. Out here, it's not. Although, if you wrote this as delta y, this would be y minus 5, right? And that's a positive 5 in here. You would be asking the same question. How come that says minus and that is a positive 5 in there? Same reason, okay?
Wait, Mr. Osdahl, could you recap that in the positive, just very briefly, only a couple of seconds?
That's positive 5 and that's positive 5. But if you were to subtract 5 on both sides, a student would look at it here and say, well, how come that's still 5 when that's y minus 5? This is delta y right here, right?
Yes, understood.
Yeah. Okay, so now getting back. What other points would be easy or useful to consider before I go to a t-table? Or do I just need to go to a t-table?
Oh, the vertex, for one.
Well, I have the vertex. Any other additional points?
Roots, perhaps.
By the way, a drawing of how this opens would be good. Okay, but we're not doing roots yet. That's something that's coming. I don't want to do roots yet. Well, we could do them without calling them that. What would be a root? Would be making y 0?
Yeah, quadratic formula.
Okay, so yeah, but you're not in standard form, so you don't have an ABC.
And to convert it to standard form.
We don't want to do that. We want to use the form we have now. So how about a t-table? So I have xy. What I do is I put my vertex I know is in the middle. I also know that my axis of symmetry here is at that x coordinate. X equals -2 is the axis of symmetry. I know that any point I find to the left is going to be mirrored to the right.
So, Mr. Osthal, how did you get, oh yeah, you use -b over, wait, no. How did you get the x coordinate for the axis of symmetry? Yeah, vertex, sorry.
How did I get the vertex? It's HK is here.
Oh yes, it's
And then-
negative.
And that's
Yeah.
the x coordinate right there. So the line that goes through it is x equals that x coordinate. X equals -2.
Well, why'd you have -2 instead of 2 if you're adding it in the form? Oh, you're all right, because x needs to be set back. Never mind.
Good.
And y doesn't affect it.
Okay, and now, okay, so now that I have that, and I'm going to use what we know in geometry about reflections, I really only need to find 2 other points then. And I'm going to go one direction that's easier for me to plug in. So how about I plug in a -1 and maybe a 0? If I do that, a -1 would give me the same answer as what? It would give me the same y value as what? 1 away in one direction from -2.
1.
Right?
Wait, no. Yeah, no, wait.
One away that way,
Zero,
and 1 away that way would be the same value.
-3.
Yeah, -3. 2 away to the right, 2 away to the left. So you pick which ones you want to find first. I'll plug in a -1. -1 plus 2 is 1. 1 squared is 1. 1 times -1/4 is -1/4. -1/4 plus 5 is 4 3/4. And now I have 4 3/4 for both because it's a reflection. If I plug in 0, 0 plus 2 is 2. 2 squared is 4. 1/4 of 4 is 1, and it's negative. -1 plus 5 is 4, and so this one is 4. And now I have points that I can graph. All right, so I'll hold this down and then we'll finish up. Okay, so I'm going to stop the share, and everybody can follow here. And then this is what it's going to look like. I'm not going above 5 there. And over here, I'm not going past there. Okay, so my vertex was at -2, 5. My sketch shows it's going to look like that. And so I recommend to you guys to do a little quick sketch of what it's going to look like based on that, to remind you of how it's going to look. And then you know along the way, oh, you keep checking all of your stuff to make sure everything's reasonable. Okay, and then -1 is 4 3/4, platform 9 3/4. And then over here on this side, it's a reflection. So here.
I know that's a movie reference, and I have a faint suspicion I know what movie it is.
That's a book
Harry
reference.
Potter.
That's a
I
book
thought
reference.
so.
Don't call that a
Both
movie
are in-
reference.
I have a feeling that you think lesser of people that are into Harry Potter then. Okay,
I
now
don't
here's
think what I
just
don't.
a side here before we go on dismissal. What Søren is saying is, I don't know where this is going to cross. So before we learn that, this is going to be inaccurate where I do that, which we don't like that because these crossing points are going to be important. Okay?
Which are important.
Where the golf ball landed, that was an important point. And by doing it this way, my graph is not going to be accurate where that hits. So by finding out what Søren called the roots, that's going to be important later. We're going to want to know that. So right now with these points, it didn't really tell me where those were. How would I find them? Well, at both of these points, what they have in common is that they're both on the x-axis.
X0.
No, y is 0.
Y0.
So then you would want to make this y is 0. Okay? Then you have to solve it.
Quadratic equation.
But solving it though, it means unraveling all of this. So it kind of, this form is not necessarily the best way to do the graph when you're interested in these points. Not necessarily. It's fine. I mean, you can still manipulate the equation.
So what is the point of using that equation?
Point.
Ha ha ha.
Sorry.
Wait, can you
Why
explain
would we
how
use
you got
that
the
equation over
vertex?
the other one?
This one was awesome for locating the maximum point. Instead of using negative b over 2a, this gives us the maximum or minimum point immediately, negative 2, 5.
But
how do you know
how
it's
do we
negative?
convert between the two equations?
Oh, just square it. Square it, multiply, add 5. Just expand it out. All right, you guys are dismissed. We're on office hours.
Thank you, Mr. Rosenthal.
Thank you.
Oh,
Wait, so Mr. Rosenthal, I have a question about something.
Okay.
How did you get negative 2 out of 5 when inside it's plus 2?
Okay, so if you forget everything else, this is horizontal movement, no vertical movement, right? So it's a question of whether it goes right or left. Before there was a plus 2 there, you just had y, the parent function is y equals x squared. So let's get rid of everything else. Okay, parent function is this. The vertex is at 0, 0. We're not going to move it up or down. We're either going to move it left or we're going to move it to the right. No up or down movement. Okay? So what we're going to do now is we're going to write this plus 2 like you have it there. And you're trying to determine, is it going to move it right 2 or left 2 based on this? Well, let's track that point. That point is going to only move left or right. And because it only moves left or right, the y value is not going to bump up or down. So the y of 0 is going to stay put. Watch here. Well, how are you going to get this to be equal to 0? It only if x is the opposite of that.
Oh, okay.
Which bumps it left to negative 2. Okay?
And then you get the plus 5 just from, the
Yeah, and
5.
adding 5 on the end is going to send it up 5 spaces up here.
Okay, thank you, Mr. Rosenthal.
You betcha. Don't you know?
David, sir, do we have an English meeting today?
I think I don't know about an English meeting. I think we might, but I do know we have a science bowl meeting at 1.
I'm pretty sure.
Science bowl.
I'm pretty sure there's an English meeting right now. Microsoft Teams.
Oh, really?
I mean,
I
I've
have
got chemistry in
I have purple
20
comic
minutes.
math competition with Bohang today at 5.
All right. Thank you, Mr. Rosenthal. Have a good day. See you
Thank
tomorrow.
you.
Bye, guys.
Bye.
Have a good afternoon.
You as well.
Bye.
Bye.
Thank you, Mr. Rosenthal. Have a good day. See you tomorrow.
You betcha.
No, and I have something else to ask that's not related to the lesson. So you know how in the homework, like